So area between a curve and the axis, or between a curve and a curve, definitely that's yesterday. So those are not on the test. The most recent stuff on the test is step 58, which was before spring break. Spring break. Oh, whatever. Thanksgiving break. My bad. Definitely not before spring break. Okay, so the inverses. Fine. By the way, if I were you, if I didn't give you this to study, which is probably going to be the case in the future, so you start to get practice studying from that test, then I would start with the most recent set, 58, look at the notes, look at the practice problems, go until you feel like you're solid there, then go on to 57 and work your way down. That's how I study. That's exactly how I build this. I look at my notes that I did because that contains what I consider big ideas for set 58. And then I built my outline from there. So these are just nothing more than shortened forms of the notes that you were already given. Find an inverse by. How do you find an inverse? Switch. Okay, now I'm going to put switch period. Because once you switch, you did find the inverse. Now, I beg you, use the given notation. By that I mean, if I give you y, use y. If I give you f, then use f inverse. I will clarify. If I say, what is y equals e to the x, or y equals e to the x, what's the inverse? Then what's the inverse? X equals e to the y. If I say f of x equals e to the x, what's the inverse? Then you would say x equals e to the f inverse. Right? The minute you switch is the minute you use inverse function notation. That's why I prefer function notation, because it allows you to say this is now the inverse, whereas the y is supposed to say. All right, you with me? A little bit of vocabulary. Sometimes it'll say find the inverse explicitly, or the explicit inverse. That means you must solve for the inverse. Okay, so for example, in this case, x equals e to the f inverse, that's not explicit. That's not solved for. This is implicit. Implicit means you do not have to solve. So let me give you a real quick example. If I said y equals whatever, square root of x plus 3, all in square root, then what is the inverse implicitly? The inverse form implicitly. What is it? Ow. Flat penny. X equals square root of y plus 3. Boom. Okay? I found the inverse because I switched. It's implicit because I did not solve for the inverse. I just, boom, left it there. Implicit means the inverse is in there, it's implied. But I didn't explicitly state. I know you guys think explicit is like cuss words, but explicit means clearly stated, all right? Or some of you think that. If I asked you for the inverse explicitly, then you would have to, besides switching, then solve. And so what is the explicit inverse, or the inverse solved for? Y equals x squared minus 3. Okay, that's the explicit or clearly stated solved for inverse. You follow? We could prove an inverse by showing what? How do you prove inverses? Missing out on a chance for education by participating. If you compose or put one into the other, you should be right back to where you started. And if they ask you to prove, you must show both. If you put the inverse into the function, you get x. And when you put x, or the function into the inverse, you get x. Or whatever the word is. You follow? Okay. I could, for example, show these are inverses. Actually, I shouldn't have used y notation. It's easier to show that with inverse notation. But if I were to put x squared minus 3 into the function, x squared minus 3 plus 3 would be x squared square rooted, which is x. If I put this into that, the square root of x squared, x plus 3 squared is x plus 3, minus 3 then is x. So if they're truly inverses, they should cancel each other's effects out. Inverse graphs. Inverse graphs are symmetric about the line y equal x. Okay? So for example, if I had a graph that looked like this, then the inverse would look like, would it open left or right?
Right.
Can you tell me? This here, it seems like as x is going to infinity, y is going to negative infinity, yeah? Now those are going to switch. So as y goes to infinity, x goes to negative infinity. It's going to open. You could use this, if just because these points are obvious doesn't mean you can't make this point. Call it 0, 1. Switch it, boom, there's 1, 0. That also shows you can get infinitely many points by just saying, what are the coordinates of that? Now switch the x and y. There's your new point. What are the coordinates of that? Switch the x and y. There's your new point. You can get tons of points and boom, you graph. Okay, so if you're not sure, just make lots of points and switch. Cool? All right, if the original is 1 to 1, then the inverse is a function. You could think graphically, if the original passes the horizontal line test, if the original passes the horizontal line test, then the inverse passes the vertical line test, and therefore is a function. Boom. All right, and then inverse trig. You need to understand the difference between these two questions. I didn't teach you trig, so I don't know if you are clear in your head. But there's a difference. There's a ton of overlap, but there's also a difference between these two. They both ask the same thing. They both say, at what angle is sine root 2 over 2? There is a difference, though, because this doesn't have any implication about what kind of answers. You can give me a billion different answers. What kind of angles does sine equal root 3 over 2? Pi over 3. What? 2 pi over 3. Around again, so 7 pi over 3. 8 pi over 3, and so on. I could give infinitely many answers. Tons. Forever. This is restricted. Now, it's restricted so that it's a function. When you put in root 3 over 2, you should get one answer out. Not 5 different answers out, one. And therefore, in order to give one answer, we have to decide, all right, where are we going to give those answers? For sine, you will always need two quadrants, one for positives and one for negatives. For sine, you get positives in the first quadrant and negatives in the fourth quadrant, but it's negative pi over 2 to pi over 2. So just so we're clear, if I ask what's the arc sine of negative 1, you wouldn't say it's 3 pi over 2. You would say it's negative pi over 2. Okay, it has to be in that acceptable range. Arc tangent and arc cosecant are the same. Tangent makes sense because you still get positives and negatives in the first and fourth. I feel like it makes sense anyway. Arc cosecant also makes sense because it's related to sine, so of course it's going to be in the same quadrants. Arc cosine is going to be different. Cosine is the adjacent side, right? And the adjacent side is the x side. Well, isn't x going to be positive in both of these regions? So it wouldn't do to go first and fourth for cosine. We wouldn't pick up any negatives. So you've got to go a place where you get positive adjacents and negative adjacents. So our cosine is from 0 to pi. And so is our cotangent. And our cosine's reciprocal, arc C. Okay? You should be able to do those. There's going to be 10 or so, I think, unless I change the test. That's 10 points right there. I hope you can do them one. All right? And it's my expectation that you can do them fairly quickly. You have some trig practice, or some inverse practice. Now skip down to where you see the notes for set 57. They might be on the second page. Are we on the second page or still on the first page? Still on the first page. Okay. So here we go. Properties for the definite integral. Some of these are obvious, and it feels like the rules are all obvious, but the problems are sometimes not so easy. So don't have a false sense of confidence. Be careful. Additivity basically means if you took the integral from 0 to 2, it doesn't have to be 2. I just feel like students understand numbers better than A and B and C. And then I went from 2 to 4. Well, the area from 0 to 2 and 2 to 4 added equal the area from 0 to 4. In other words, 2 adjacent. It's just like distances. If you say, what's the distance from 0 to 2, and the distance from 2 to 4, it'd be the same as the distance from 0 to 4, right? All right, that's additivity. Switching bounds. If you had, say you had a case where the limits of integration were backwards, instead of going from lesser to greater like they should, which is to say left to right when you look at the x-axis, they're going right to left, or greater to lesser. You can switch those limits if you negate. That's because the dx or delta x is negative. We're changing x negatively if we go from 2 backwards to 0. So it's the opposite. Switching the limits of integration gives you the opposite of the normal. Coefficients and sums. If you have, say you had something like 2f plus g, is it not allowed to break this up into 2 integrals, f and g, and the coefficient you can move out from, right? Bounded f means bounded area. If I told you, if you're given that f is less than 5 on an interval, say 1 to 4, then that, hey, y is only this big, implies a restriction on the area as well. The area under f on 1 to 4 must be less than the area under 5 on 1 to 4. Now, the area under 5 is nothing more than a rectangle, right? The area, the integral from 1 to 4 under 5 is just the area of a rectangle from 1 to 4, 5. This would imply then that the integral from 1 to 4 of f must be less than what? Let's go, Landy, what do you say? 15, thank you. All right. So by f being limited to f, f could be, anywhere in here. Maybe it reaches its max at some point of 5. So obviously the area under f would be less than the area at its max value. Okay? Even odd. If you went from -2 to 2 and f is odd, then what must it equal? 0. And that's because odd functions have symmetry about the origin. So if it's on the same side, it's same on either side, but one side's negative, then that integral must be 0. If you went from -2 to 2 and f is even, then there's symmetry, but about the y-axis. So it's not going to be 0, it's going to be double what it is on the right-hand side, or the left-hand side, I suppose. Okay? You follow? All right. And then U sub, just remember that U sub is used anytime you have a function within a function on an integral. So for example, if I told you, what's this equal to, and I gave you some stuff about f, you would right away say, 4 minus x inside another function, you would U sub, and you would let u equals 4 minus x. And then you'd be very careful about finding the du, which would be negative dx, and then isolating dx, because I don't have a negative dx, I have a dx, so you would have to move the negative over. And then you would also have to change the limits of integration to fit the mean factor. Right? Now that's all U sub skills, which I'm about to talk about next. All right? You need to be able to do U sub with the ugliest possible cases. Anytime you have a function within a function, you'll need to work with the U sub. If it's an indefinite interval, for example, if I had something like 2 plus cosine of 2x squared sine of 2x dx with no limits, then you U sub, integrate, and then you must sub back in for the u on an indefinite interval. But if it's a definite interval, it has limits of integration, like this one, then you U sub, you must change the limits of integration to match that u. And now those values will become different than 0 to pi. They'll be u values rather than x values. And because of that, after you integrate, you don't sub back. You just plug those u values in for u. You follow? Okay. Look at 7 real quick. I bet you think that's not a u sub problem. It is. What's u? You could do e to the x, but you don't want to do e to the x. Okay, actually, that's a great idea. Let's go, is u e to the x? Good thought, but what's the problem? Du is e to the x dx, and you don't have a numerator e to the x, right? So good call, good try, no dice. Not x. Okay, I beg you, develop the skill of making your life easier by rewriting the problem. Rewrite the problem. E to the, it is a function within a function. U is negative x. Okay, that is the most missed question. I'm talking good, that's BC people miss. Okay, because they think, oh, it's not a U sub problem, they crank it out. That's a U sub problem, and you have to be careful how you make that. You have to think, how is that going? Du is negative dx, and therefore negative du is dx, and you have to change the limits and so on. But I guarantee you, at least half the people would bite on the positive form of the answer that's not, doesn't have a negative, because they don't U sub it properly. Okay? This one's obvious U sub. It's the ones that are not so obvious that are really hard. That's pretty easy. Okay. Moving on to topic. Yep. Okay. Boom. I feel like I'm missing one. I'm missing one topic here. Give me one minute here. Sorry. What the heck? Nope. What is that? Oh, that's why. Stupid Google Doc. Sorry, just 1 minute. Okay, apologize. Okay, now, 55 in the book was the Maclaurin series. That's a Calc 2 topic. I didn't teach it. If we have time later on, it's pretty great, actually. But I just don't have, I just think it's out of place. There are bigger fish to fry right now. They're Calc 1 topics. So I replaced it. Therefore, you're going to want to weigh on your notes, not look at the book. 55 is a lot of outside the book, especially AP type problems, all right? I guess you could boil it down to 4 different types of problems. They all involve the fundamental theorem of calculus or integrating and talking about how you can use those integrals, its applications of integrals. One type is if I give you an f prime graph, you make inferences about f using the f prime graph. You could do a million different calculus ideas this way. For example, f is increasing where what? F prime is positive. So you look at where's the f prime graph above the axis. Okay? You could say f has a max. Where? Big idea of calculus. F has a max where what happens? F prime changes positive to negative, yeah? So you would look at where does the f prime graph go above the x-axis to below. You could do a stinking, well, actually, I'll come to that in a second. You could say, where's f concave up? Now, this would require you to take 2 steps of reasoning. F is concave up where f double is positive. Now, if you're working with an f prime graph, then how do you extract f double sine from f prime's graph? It's beautiful. You guys are good. Okay? F prime positive, f double is positive where the f prime graph has positive slope. Or you could also say where the f prime graph is increasing. Those both are totally true and acceptable. Okay? What about if I asked you, where does f have an inflection point? F double changes sign. Now then, in turn, connecting that to f prime, that would mean you need to look where f prime slope changes. And this rationale is exactly what I would write, you know, what you're thinking about where you're going to look, write that to say, all right, f has an inflection point is where f double changes sign, which is where f prime slope changes sign. This is at blah. That's your reasoning. It says justify, which it will. That's your justification. Follow? What if I asked you for to find an f value given an initial condition? So, for example, if I asked you to find f at 2 given f at 0 is 3 or something like that, how would you do that? You had it, assuming you had a graph of f prime. Maybe it looks like this. Fundamental theorem. Okay, you should. I go way back to the very drawing board. I relate these two, 0 to 2 of f prime. By fundamental theorem, isn't a definite integral mean you take the antiderivative, which is f, at the upper minus the lower? So isn't this equivalent to f at 2 minus f at 0, right? I would then isolate what I want. I want f at 2, so if I move f at 0, f at 2 is f at 0 plus the integral from 0 to 2 of f prime. Then I would usually find this by geometry. Or sometimes they'll just give it to you. They'll say the area from 0 to 2 is 7 or something like that. Okay? Are you with me? All right. What if I... Yeah, that's good. You could also I'm trying to think of every possible permutation. On an AP problem, you would probably have 4 of these pieces somewhere. Okay? What if they asked you to find a tangent line? What are the components you need to find a tangent line? The slope, okay? How would you find the slope to a tangent line to f? Yeah, you'd say it's the derivative, and therefore, if you have f times graph, you would just be using the graph, right? F prime at 3 is my slope. Then you would also need a point. Now, they'll give you the x. They'll say, give me a tangent line at x equal 2, so you won't have to manufacture an x. You'll have to find the f at that x by doing this kind of stuff, fundamental theorem of calculus. If you want to find f at 2, you did the fundamental theorem of calculus. So you'd have to do all that stuff to get the point, then put the slope and the point into your tangent line. You with me? Okay. There is a gob of overlap between that and an integral defined function. Whether you're talking the previous problem, f prime graph given find f, or this problem, say I asked you f is, actually I would give you G's graph given. And I would say f is an integral defined function. So say maybe the area from 0 up to some endpoint x under the curve G. Now, I know it feels like this is, well, it's a little more freaky looking. It's got an integral and stuff, but these are the same, pretty much the same. They're the idea of a derivative implying about the antiderivative. Well, same deal here. The antiderivative is what I'm going to use to imply. So these are almost all the same ideas. F prime, what's F prime equal to? If I took the derivative of both sides. G, if I wanted to know about F double, how does it relate to G? G prime. You would write that right away. You'd say, hey, these are the big ideas of the problem. That alone would cover you on a lot of points. I mean, that probably would get you 3 out of 9 on an AP for your response. Just writing those 2 little ideas. Okay? Or these 2. Then you have all those ideas. You could say, where is F increasing? By connecting it to G. F is increasing where, let's say F is increasing where F prime is positive, and that means where G is positive. And then you read the G graph. And so on. All those, the fundamental theorem, the F double kind of things, all still there. So a lot like the previous notes. With me? Okay. Word problems. Given a rate of change, there's 2 types of word problems with rate of change. There's just a generic rate of change, and sometimes it's positive, sometimes it's negative. If it's a single rate of change, think of it, maybe it looks something like this over time. Okay? Now, this is different than, you're being given the amount of time. Here you're being given the rate at which the amount changes. So you could actually think of this like being given the derivative graph. This is the rate of change in the amount. R is a rate at which some amount changes. Okay? It could be motion, it could be a lot of things. But what would you know about here? When R is positive, then the amount is changing in a positive way, which implies the amount is increasing. Here, the rate is negative, so the amount is decreasing. What about at that time? This time. At this time, rate went from increasing, or the amount went increasing to decreasing. So at that point, if the amount went from increasing to decreasing, there must have been a max. Okay? All right. If you wanted, actually, there are two types of problems involving an integral. If I said interpret that, what is it? Is it the amount at time 7? No, it's not. It's the change in the amount. From time 0 to time 7. That represents how much change in the amount. To find the actual amount, you also need to know the initial condition. Okay? If I had the amount at time 0 plus an integral, well, that would be the starting amount plus the change in the amount. What would that represent? That's the start plus the change, which gives you the total amount at time 7. What it started at plus how it changed gives you what it ended at. You follow? Okay. That's a single rate that could be positive and could be negative. Sometimes they break that rate into two pieces, amount of increase and amount of decrease. For example, I keep giving you problems at a rate of this, and you try and do problems at a rate of that, well, then you'd have a net rate. Okay? If I'm giving you more problems than you're doing, then the amount of problems you have is going to increase. And if you're doing problems faster than I can get them to you, the amount of problems will decrease, right? So it'll be a rate in, rate out kind of thing. So imagine you had I of t is a rate in, or a rate at which something grows. And L of t is a rate out. Then if I gave you two graphs, say this is I of t, and this is L of t. Now let's go 4 to 7. Okay? What's happening on 0 to 4? In terms of the number of things, the amount is. Now look at which one's bigger, has a greater rate. In time 0 to 4, which is greater, in or out? In. If the in rate is greater than the out rate, then that's like me giving you more problems than you're getting, and so the amount will increase or decrease? Increase. If the in is greater than the out, then the amount of problems, or the number of whatever, is increasing. The amount is increasing because the in rate is greater than the out rate. So you'd say on the region from 4 to 7, the n number of things is decreasing because out is greater than in. What about at 4 then? Is that a max or min? Max. The amount went from increasing up to 4 and then started decreasing after. So at 4 there must have been a max number of factors. You follow? Okay, what if I asked you this? What does this represent? The total or change in the total? Because I can't know the total unless I knew the dish, okay? So it is the change in the amount from time, actually let's change this to time 2. From time 0 to time equal 2. If that was positive, what would that imply? Yeah, in that 2 hour span, more people came in than left, or whatever, right? And the amount at 2 is greater than it was at time 0. What if I asked you this? Amount at 0 plus 0 to 3, I minus L. What does that represent? Okay, at 0 means the starting amount. What's the change in the amount? Is total amount, the ending amount, or the amount at time. Okay, finish plus change gives you n. All right, that is good. Last but not least, topic 54, step 54. Velocity, position, acceleration. I can imagine 3 different types of problems. Depending on what I gave you, you should be able to find the other 2. But you should know how position, velocity, and acceleration relate to each other. And if I give you one, you should be able to find the other 2. If I gave you position, now that could be either something moving vertically, so I might call that h of t or y of t, or it could be moving horizontally, which I might call x of t or s of t. S of t is used for lots of position functions. But if I gave you position, how would you find velocity? Velocity is the derivative of position, and acceleration is the derivative of velocity or the second derivative of position. Yep. So you take derivatives there. You follow? All right. What if I dropped you in the middle and I gave you velocity? How could you find acceleration? Would you take the derivative of velocity or anti? Derivative. Acceleration is the change in the velocity over time, so it's a derivative. It's the derivative A equals V prime, right? How would you find position if you're given velocity? Antiderivative or integrate, and you'd have to use the initial condition to find the plus C. Okay? The minute you integrate, you get a plus C. And you have to have an initial condition to find that plus C. They will give you. Okay? Say I gave you acceleration. How would you find velocity? Integrate and use the initial to find that first plus C. And how would you find position? Integrate again. Integrate velocity. And use that velocity or position initial, position given, to find the next plus C. Right? Those are big ideas of calculus you ought to be good on. There's practice. That's it. Boom! I will be here 7th hour. I will be here after school. I'll be here before school tomorrow. Whatever it takes for you to succeed, I will match you in up one. Yep. So, yeah, no, I get you. So, if I told you that velocity is 3t squared plus 5t plus 1, and I told you the position at 1 is 4, what is position? You would integrate, like you said, x is the antiderivative of v, so you'd integrate 3t squared plus 5t plus 1, yeah? Now when you do that, you get x is t cubed plus 5 halves t squared plus t plus a constant. Now the only way you're going to find that constant is if you have a t and an x to put in. That's what the initial condition does. They say when time is 1, x is 4. So if I have a 4 there, that implies that C must have been. C, so this velocity, so how do I solve for that C? See, okay, so good question. Velocity is the derivative of position. So when I had that initial position and I took the derivative to get that velocity, it could have had some constant over here that went away. I have no idea what that constant was that went away because it's not there anymore. So it's because when I took a derivative, I could have had any unknown constant. That's what the C stands for. Some constant that must have been there, but I can't know it unless I have more information. And that's where that initial condition comes in. The only way you can find what that constant was that went away in finding the velocity is if you have some kind of x at time node. Once you anti-differentiate, you have to use the initial condition for t and x, and then and that's what will allow you to find the c. And then once you know that c, then your final answer is blah 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 blah. Question. Yes, exactly. After you find that c, which is a number, your final answer will be t cubed plus 5 halves t squared plus t plus whatever you found. Yeah. Your final answer is x is a function of time. What is x as a function of time, and what was the c? Okay? Yes? What? Oh, the... Yeah. Sorry about that, I missed the phone. Okay, so you all got the review, although it's a little late now. If you really don't, if you didn't get the review and you sat there the whole thing. No offense. But you all have those two? Okay, the review is not an assignment. It's optional. Do whatever you think will help you, or blow it off if you are dropping hundos and you want to see if you can drop a hundo without practice. Cool. But this is the assignment that's due Friday. Okay? Questions on set 60. For which? 23. Somebody said something over there. Speak up, girl. Oh, yes. Sorry. Replacements. 23 you said, I think. Is that what you said, Lainey?
Yeah. Replacement, that's after 12.
Replacement after 12 questions. What else? 4? 1, got that.
8. No, 9.
8, no, 9.
9.
Okay.
8.
8 and 9?
Just
Messing with me? All righty. Do. Okie dokie. Okay, here we go. So this is an example of enter versus leave. The dummy variable component where you're writing an integral, that I feel is a little new, so you wouldn't see that on the test. But anyway, you didn't have to show the picture, but just to remind you, this is what mine looks like. This is the enter function, and this is the leave function. Like that, yeah? Okay. Graph both in your calculator and sketch to the right. Identify regions of time when the number of it is increasing or decreasing. Wouldn't you agree that it's increasing when the enter rate is greater than the leave rate?
yes.
Okay. So in this section where the blue curve is above the red curve, then their cars are entering faster than they're leaving. So in this section, the number of cars is increasing. I wish I would know. You get the idea. Increasing. Okay? Therefore, the places where the red is greater, the car numbers must be decreasing. So in those green regions. You follow? Do you agree? Okay. If the lot had 25 cars at 8 a.m., how much does it have at noon? The big idea is the amount at later in the day is a starting amount plus the change, and the change is really a source of increase minus decrease, right? Big idea. Start with the big idea, then get into the nitty-gritty details, right? Now, I know that the starting point is 25 cars at 8 a.m. That's what they give me as a reference point. I then need to talk about how much will things change from 8 a.m. to noon. Well, what are the limits of integration? It has to do with how they define T. I don't know if this bothered you, but this should have been T, sorry.
Good morning, Devlin Jaguars. Please rise for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
So they define T as
The
time
Colorado
since
School of Mines
mid.
Multicultural Engineering Training Program is a science and engineering program designed for rising juniors and seniors who are from underrepresented
So
classes,
8 a.m. the
including
starting point would
minority
be
rural
8,
areas and women.
and noon is
Women
12.
and board, room and board, meals and course materials are included.
Enter
Stop by counseling for information.
minus sleep.
Today, Colorado Mesa
You
University.
could also do this as 2 integrals. It's fine too.
They
Okay.
are known for their outdoors adventures.
With me?
Stop by counseling.
Now, if you do that, then I got
Students, please don't forget to vote for the Blue Book
58.9224,
awards in the library or online. Remember,
or
only
roughly
you can choose the
59
winner for
cars.
this year and the nominees for next year. Let your voice and choices be heard.
Show both. If you're not sure whether to round or not, show both.
Featured in this year's yearbook.
Cool.
Send your Snapchat and Instagram pictures to yearbook email at yearbook.jag@gmail.com before December 7th. Make sure to
Daily
add
period is 2 pi over 4.
sweet pics.
The shift is
Come see the
right.
Dublin State Champion Marching Band
Pi over
Parade
2.
of Lights downtown this Friday, November 30th at 8 p.m.
Period is 4
or
pi.
Saturday, December 1st at 6 p.m. That is
Left.
all your announcements. Have a great day.
2 pi. Period is 2. Shift is left 3 over pi. It goes. Now, apparently some of you really hate trig. No, you don't. Okay. G at 0 was 2. G prime at 0 is 2. And G double at 0 is 1. I justified why those are on my work. Okay? Concave up is where G double is positive, which is where F prime is positive, which means F has positive slope, right? Which is on -2 to 4 and 8 to 9. We? No, 7 to 9, right? It should be 7 to 9, shouldn't it? I have 8 to 9, but that's a mistake. It's 7 to 9. -2 to 1, yes. Why did I say? What did I look? Oh, I'm looking at C. Dumb, stupid. Sorry. I was looking at C's answer. -2 to 1 and 7 to 9. Okay. C then was, hi.
How are you?
Super, thanks, pal. Okay. C is -2 to 4 and 8 to 9. All right. Boom. 23, check. 23, no, not check. 23. Do you have questions about 23? By the way, the key is online. So hopefully that'll help you get started. 23. Shall I expound or questions? You're good? Okay. Okay. What about 1? Okay? One they gave you that this box has a square base, and I don't know what the height is. They also gave you that the volume needs to be 1,000. They want you to minimize the surface area. Start with what you're trying to minimize, which is 2 area of the base, or 2x squared, plus the perimeter of the base, 4x, times the height, y. Then sub in for y to get it down to 2 variables. You know from the volume that y is 1,000 over x squared. So if you substitute that in, surface area is 2x squared plus 4x times 1,000 over x squared, or 2x squared plus 4,000 x to the negative first. If you then find where a prime goes negative to positive, you'll find the minimum surface. I did 4 on my. I did 4 on the key and 9, so hopefully you're good. Okay? Look at the key online if you're not sure. Please make sure I get this by the end of the day. Have a lovely day.